Here we go. So we have, let's see, how many more classes do we have? We have today, right? Tuesday. And then we have Thursday. And then next Tuesday. And then nothing on Thanksgiving. So then the following Tuesday and the following Thursday. And that's it. So 5 classes including today. And then we have a final after that. So I don't remember. It should be on the syllabus, which we can look up. Not right now, but we'll look it up later. So we're only going to meet 5 more times, which is good news, I guess, right? It's both. It's kind of, I am going to miss everyone. I might just fail that table. That way you can come back and we do it again next year. You want to do it next semester? That's right. All right, so we're going to do something today. Systems of equations. Some of you may have done this in the past, so I wanted to do this a little different. I wanted to show you something visually. Let me just get this thing open. We'll talk about that after Thanksgiving. Yeah, be here after Thanksgiving because that week before is when we're going to talk about the final. We'll spend 2 days talking about what's going to be on the final. I apologize, my Okay, well, I'll look for this in a second. I thought it was right here. I don't see it. Oh, there are those files I was looking for. Okay, I need to get on track. I'm sorry. Let's go. Let's do this. All right, so let's talk about systems of linear equations. Oh, and so the tests I thought were good. All right, just class average 81. That was pretty good. I know it was a little challenging, but we're done with logs. All right, we're done with all that. Until the final, yeah. So let's first talk about what a linear equation is, and then after that, what a system of linear equations is, and then we're going to actually go from equations to what are called inequalities, but it's kind of one step at a time here, all right? So first of all, a linear equation, by definition, is an equation with variables raised to first power only. So any equation that has variables in it and those variables are raised to the first power is a linear equation. And I'll give you a few examples. X plus 4 equals 10. That's a linear equation, right? Everyone agree? It's an equation. It has a variable in it, and what's the power on that x? 1, even though we don't write it. Right? So that's a linear equation. This right here we would call, I'll put it next to it, a linear equation, one variable. Meaning that there's only one variable in the equation. Now, what kind of answer do we get if I were to ask you to solve that equation? What would we get? X is 6, right? Which is basically a number, a single value. X is 6. Agreed? Compare that to this. X plus y equals 10. Now, first of all, is that a linear equation? Yes, it's an equation. It has variables in it. Each variable is only raised to the first power. So that is a linear equation, but it's not a linear equation in one variable. It's a linear equation in two variables. Now, what is that? If I ask you to give me the answer to that, what are you solving for, X or Y? Well, what would one example of an answer be? If give me an X and a Y that would make that true. 5 and 5? Is that the only answer? You could go all day long, right? You could just get answers all day long. And if you remember, it's been a long time, but if you remember, if we solve this for Y, graphically, what is that? Y equals that, negative X plus 10. What is that if I were to ask you to graph it? No, it's not me running. Okay, is it an exponential function? Is it a log? Is it a rational function? Is it a polynomial function? It's a line, right? It's a line. That's a line. Y equals mx plus b, isn't it? Isn't that y equals mx plus b? It's been so long since we've done that, I guess you forgot, right? Y equals mx plus b. Everyone agree with that? So is that something that you could graph? Yes? And remember that when you graph this, right, when you were to go and graph this, it would be y-intercept of 10 and a slope of -1, which would mean that the line would look something like that, right? Not a very good line, but, right, that's what it would be. And each point on that line represents a solution to that equation, doesn't it? That's what we've done in the past. Now, I could keep going all day long, giving you examples of linear equations and just adding more variables each time. So like, how about this? What's x plus y plus z equals 10? Is that a linear equation? Yes. How many variables? 3 variables. Now that's as high as we're going to go in this class. We're going to go to linear equations with 3 variables. So let me kind of take a step back so we can see all 3 of these together. We have linear equation 1 variable, linear equation 2 variable, linear equation 3 variable. We know with the first one, we said that the solution to that was a point, right? X equals 6. That was a point. You could look at it like on the number line, it's the value 6, right? It's just a point. This one right here, the solution to this was a line, right? I wonder what this is. What's the solution to this? Well, it turns out that if you have 3, let me try and force it to come out of your head. Let's see. If I have the first equation, x plus 4 equals 10, my answer was on a number line, right? Number line 6, right? In the second equation, when I had 2 variables, I couldn't look at it on a number line. I had to look on it like an XY plane, right? On a graph. And my answer was a line on that graph. Now that I have 3 variables, what do you think I'm going to need to visualize the answer? I can't use a number line. It's going to be more than just this. So what do you think? Anyone have a guess? I'll give you even more of a hint. It's not 1-dimensional. It's not 2-dimensional. It'd be 3-dimensional. which means that your answer turns out to be like, imagine that we had, and we haven't done this, this is why it's awkward. Instead of having a number line like this, and instead of having two-dimensional space like that, like a flat sheet of paper, imagine three-dimensional space that would look something like this. It's almost like, look at that as being like the corner of the room, right? The corner of the room. The floor over here, this is, let's say this is the floor of the room. This is a wall. This is a wall over here. Do y'all see it? It's like that over there. With me? We would call this the x-axis, the y-axis. So in other words, the ground is now your x and y-axis. It's that two-dimensional plane, but we're laying it down on the ground, and then we're sticking a third axis up out of the ground. A little bit. So now we have three-dimensional space. The solution to this linear equation in three variables turns out to be a sheet of paper or a plane in three-dimensional space. So imagine taking a sheet of paper in this room and putting it like this somewhere, okay, and that would be your answer. All your answers to that equation are every point that lives on a plane. Now, we're not going to get into too much of that right now. We're going to spend a lot of time in two-dimensional space today and next class, all right? But I just wanted you to see we could keep going. Once you get into linear equations, if I were to have four variables, well, now you have a huge problem. There's only three-dimensional. We live in three-dimensional space. The fourth dimension is hard to visualize. And then there's fifth dimensional space, sixth, seventh, eighth, ninth, 10th. And it turns out that there are some very brilliant mathematicians who are blind. And part of what makes some of the math easier for people who are blind is the fact that they don't visualize three-dimensional space the way we do. So it's easier for them to understand higher dimensions because they're not fixated like we are in three. Does that make sense? Yeah, we're kind of stuck in the box, three-dimensional. All right, let's get back to two. This is where we're going to spend all our time right here today. That's a linear equation in two variables, right? It's a line. What we're going to investigate now is a system of linear equations in two variables. So that's what today is about. What is a system of equations in linear of linear equations in two variables? So let's go back to that problem that I just had up there. It was x plus y equals 10, right? We said there were an infinite number of answers to that, right? We could pick x's and y's all day long. Underneath this, though, let's write a different equation. Let's do a totally different linear equation in two variables. 2x minus y equals 7. Now, that is also a line, isn't it? The question for us right now is there an x and is there a y that make both of these true at the same time? Like I could pick this right here for x and y. I could pick, y'all said 5 and 5, right? Now that would make the first one true, but would it make the second one true? No. If I try it in here, no, it doesn't work. So is there something you could, can someone think of an x and y I could plug into the second one that would work? How about 4 and 1? Would 4 and 1 work in here? What's 2 times 4? 8 minus 1, 7. So that would work, right? But would that work in the other one? No. Do you see what I'm saying? So I'm trying to find an x and a y that work with both. Yeah? And it's hard to do. Just by looking, it's hard to do, isn't it? Do they work? 5 and 3 won't work on the first one, because that would give you 8. Good try, though. But it would have made the second one work. So let me try something else. If the first one up there, x plus y, if that's a line, right? If that's a line, then when I graph it, I get something, right? The other one is also a line, isn't it? And when I graph it, it does something else. So let me try and draw it in here however I want. I'm just going to draw it somehow. What do you think the x and y that works for both corresponds to on this graph? The point where? The point they intersect. See, if we can figure out where these two intersect, we've found an x and a y that lives on both lines and therefore satisfies both equations at the same time. So we're really trying to find the intersection of two lines. That's what we're trying to do. With me? All right, so now let me formally write this down. What we'll do is we'll say solve, okay? Solve this, x plus y equals 10, and the other one was 2x minus y equals, what was it, 7? Now, in order for me to let you know I want you to solve those at the same time, the standard notation is to put a brace in front of that. The brace connects the two linear equations together and says, solve this system of equations. Now, there are two standard ways of solving systems of linear equations. The first way is called substitution. The second way is called elimination. I'm going to show you substitution first, and then I'll show you elimination later. Okay, so here we go. Substitution. I'm showing you how to solve this now, okay? Substitution. What you'll do for substitution, first step, look at each equation and solve either one for either variable. Either variable. Are they both correct to say either or either? Freaking English. So there's some freedom in this process of substitution. There's some freedom as far as how you go about it. I can look at either equation, and I can choose either variable in either equation and solve for it. But you want to kind of use a little bit of logic here. Well, I have to pick either one. So let's look. I look at both of these, right? And I say, I'm going to get to pick either variable and solve for it. So if I want to solve the first equation for x, all I would have to do is move the y over, right? That would be pretty easy. If I want to solve this one for y, all I'd have to do is move the x over. That would be easy, right? On the second one, if I wanted to solve for x, I would have to move the y over and then divide by 2. That's a little more complicated, right? And if I want to solve for y, I would have to move the 2x over, but then divide by -1. That seems a little complicated, right? So you want to pick the easiest of all of those, which I would say is solve the first equation for either x or y. And it's really a coin flip now, because they're both equally easy. Does that make sense? Okay, so let's solve the first equation. So in red is the step. Underneath it, in, let's say, blue is what I'm going to do, okay, for this particular problem. So my first step for this problem is I'm going to take equation 1, and I'm going to solve for x. Is that all right? All right, so I write down equation 1, and I solve for x, so I subtract y on both sides. 10 minus y. Now, I'm going to box that. That's not our final answer, but I'm going to box that. That's what we got from step 1, right? That was our result of step 1. All right. Now, step 2. Substitute answer from step 1 into the other equation. So what we're going to do, and this is why it's called substitution, because we are about to substitute. I'm going to take this x equals 10 minus y. I'm going to substitute it into the other equation. That's the equation I didn't use, right? The other equation is 2x minus y. So let me go ahead and write down the other equation, which is 2x minus y equals 7. I'm going to substitute what for what? What do you think? A little bit, yeah, a little bit. Okay, so I'm going to take that x right there, and I'm going to replace it with the 10 minus y. You'll see that? I'm saying up here x is 10 minus y, right? So in this equation, whatever x is has to be replaced with 10 minus y. Does that step make sense as far as the words? I'm substituting the answer I just got from step 1 into the other equation. Now, had I solved for y up here, I would have plugged it in here. So we have to just pay attention to that. So let's go ahead and plug that in now. It'll be 2, 10 minus y equals 7. Now, is that correct? Parentheses, right? Because that 2 is going to multiply. So that 2 right here multiplies by the x, so that can multiply the 10 minus y. Okay, that's the step 2, substitute. Step 3, I'm going to put it here to the left so I don't have to make a new page. 3, solve the remaining equation. I'm going to put a little note here. Should only have one variable in it. So when we look at this step 2, right, I'm going to solve that remaining equation here. Notice that this equation, the only variable in it is y, right? So we should be able to solve for y. So here's my step 3. I'm going to take the 2, 10 minus y equals 7. I'm going to distribute through the 2. Gives me 20 minus 2y minus y equals 27. And then, so 20 minus, careful, 3y equals 20. Why did I put 27? I know why, because I had already moved things. I don't even know. I had a brain fart there. 7. Okay, sorry about that. My 7 didn't change yet. And it's not even going to become 27, so I don't know what I'm doing. I'm going to drop the class. Oh, yeah, it's too late to drop the class, right? Friday was our last day to drop the class. So I sent you all that email. Hopefully everyone got that. Showed you where you stood in the class, what you needed on the final, basically. All right. All right, so now let's subtract 20 on both sides. So I get negative 3y equals, what's that? Negative 13. And finally, divide both sides by negative 3. And negative divided by negative is positive. I'm not going to get a decimal. I'm going to leave it as 13 thirds. I'm going to leave it as an exact answer, as an improper fraction. Well, you remember how I was saying, is there an x and a y that make both true at the same time? I know what y is. Y is 13/3. I don't know x yet. But look back up here at 1. Don't we have what x needs to be in 1? X is 10 minus y. So if I take that y answer and I plug it in up here, I know what x is now. So that's the fourth step. Fourth step is to now take answer from part 3, plug in to equation from part 1. And you might be asking yourself, well, why isn't he just saying plug y in? Yeah, because every problem is going to be different. You might solve for y instead of x. And so I have to try and make the steps as general as possible. So I'm going to take the answer we just got, and I'm going to plug it into what we had up there in that equation from part 1. And here's the actual step. I'll put it right here. First, I'll write down the answer from part 1, which was this. And now I'm going to replace my y with 13/3, right? So x equals 10 minus 13/3. Nope, that's 13/2. 13/3. And the only way you can put those two together is get a common denominator. So this is the same as 10 over 1 minus 13 over 3, which is the same as 30 over 3 minus 13 over 3. So I multiply top and bottom by 3 on the 10, right? And subtract, and that's what? 17 over 3. Yes. Oh, well, this sign? Yes, it was minus. Now, we'd have to be careful because if our y over there happened to have been negative, this would have been minus a negative would have turned into a plus. Yeah. Okay, so that's it, right? That's it. Now, if I check this, I would have to check it just to see if it works. I'm not going to ask you to check, but let's just, since this is our first example, let me just check that it does work. I'm saying that the answer was xy. What was x again? 17/3, and the y was what? 13/3. The two equations were x plus y equals 10, and then 2x minus y equals 7. Let me try these answers into these equations. Let me do the first one. X is 17 over 3 plus y 13 over 3. Does that equal 10? 30 over 3 is 10. That works. Now the other equation. 2 times x is 17 over 3 minus y, which is 13 over 3. Does that equal 7? Well, I have to multiply the 2 and the 17. That would become a 34 over 3 minus 13 over 3. When you take 34 and subtract 13, you get what? 34 take away 13, you get 21 over 3. What's 21 divided by 3? 7. So that works. So you can see that there's no way anyone in here was going to look at those two equations in the very beginning and be like, oh yeah, 17/3 and 13/3. Yeah, it's obvious. It's not, right? It's something you have to work to get. But this allows us to do it. Make sense? Now, I mean, there's lots of applications to this. I'll give you just one quick application. Let's say that you have a company, right? And let's say this is the number of phones you create. So this is like, some cell phone company. And this is going to be money. So let's say that this cell phone company knows that they have a certain cost of making phones, right? They have to pay the people who make them, they have to pay for materials, everything else, right? So you have a cost, what we call a cost function. And let's say the cost function looks like this. I'll just call it C. So the more phones they make, the more it's going to cost, right? And then they have what's called the profit. The more phones they sell, the more money they make, right? So maybe their profit looks like this. Then what is this point here? Why is it significant? That's where you start making money, right? That's what you call your break-even point. That's where you're actually, that's the point at which it's now profitable for you to do this business. If you sell less phones than this, let's say this is like 120,000, all right? Maybe you determine now that as long as you sell more than 120,000 phones, you're going to start making money. But that break-even point is always something that business companies are trying to figure out. And in this case, it would be just the intersection of two lines. Make sense? Okay, that's just one like basic example. For us, we're just going to have equations. We're just going to try and find it using this method, and that'll be it. Y'all look thrilled. I mean, absolutely just euphoric. I don't think I've used that word this semester for you, but that's what I'm seeing. Euphoria? The what? Oh. Let's try one more. Wow. Come on. I'm going to change that a little bit, sorry. 2y. All right, what we have here is a system of linear equations in two variables, right? We have two equations. Each one of them has two variables, and they're linear. Just keep in mind that if I put up here like a squared, a squared on that x, this would no longer be a system of linear equations. And actually, we won't even touch something like that in this class. So it'll always be linear. Now, I'm going to use substitution to try and solve this. And so my first step is to pick an equation and a variable I wish to solve for. You want to do the second equation? And which variable? Y? Why? Why do you want y in the second equation? Yeah, it looks like, I mean, if I try and solve for the x in the first one, I'm going to have to move that over, divide by 3. That's not going to be nice. If I solve for y, I'm going to have to move the 3x over and divide by 2. On the second equation, if I solve for x, I have to move the y over and then divide by 4. This y right here is the only one that doesn't have a coefficient other than 1, right? Wait, is the only one that has a coefficient of 1, -1, but. So I'm going to go for the cleanest variable I can find. Now, you could go with any of them, okay, but I'm going to try and go with the easiest one. So I'm going to write this down, 4x minus y equals -12. And then I'm going to write y equals 4x plus 12. What did I do? I moved the y to the right. I moved the -12 to the left. didn't I? But then I flipped the order. So I really had this. I had 4x plus 12 equals y. But with an equation, it doesn't matter which side, right? The left and right sides, you can just swap them. Is that all right? I'm assuming everyone could have got y isolated. What's my second step? Plug this answer that I get from 1 into the other equation. Now, my other equation was, what, 3x plus 2y equals 5, right? And I'm going to replace the y with 4x plus 12. So 3x plus 2 times, in parentheses, 4x plus 12 equals 5. We good? Distribute. $11x equals negative 21. No. Negative 19. I subtracted 24 on both sides. 5 take away 24 is negative 19. 3x plus 8x is 11x. And that means x is negative 19 over 11. And I will not get a decimal. I will leave it as a fraction. You know what? This was step 4. Sorry. Step 4 was right here. That's where I'm supposed to solve it, right? Not step 4. Dang it. What's wrong with me? I know. That's what it is. You don't need to, but I know there's a lot of people who like steps. So I don't need to see them at this point. But if, you know, on the test, on the final, you'll have a cheat sheet. You can have it there. But what would the last step be? Plug it into that first equation, y equals 4x plus 12. So I'm going to take y equals 4x plus 12. I'm going to put the negative 19 over 11 right in here for the x. I don't know why I did that. 4 times negative 19 over 11 plus 12. What's 4 times negative 19 over 11? You can use a calculator. Negative 76. Negative 76 over 11 plus 12 over 1. Are y'all following this? Now I need a common denominator. So I need to multiply 11 on top and bottom on that 12 over 1. What is 12 times 11? That's 11 times 11. 132? 132? Okay, so 132 over 11. And now you're taking negative 76, you're adding 132, so 32 and 24, 56. 56 over 11. And so now I want us to write our final answer. The way I want you to write your final answer is what we call an ordered pair, which is just like an x and a y coordinate. So I want you to write negative 19 over 11 and then 56 over 11. Remember, that's your x, that's your y. Don't mix those up, okay? That's what I'm looking for. What? It's almost over, everyone. You only have to endure them for a few more weeks. 5 more classes. What do y'all think? I mean, I would say that, the issues that you might have are with the fractions, because, we try and avoid them, but in the signs, so. Oh, yeah. Most people do pretty well with this. But you have to take your time, because if you mess up anywhere, it's over. I mean, the whole thing's off. Okay, now we're going to extend on this. We still have more to talk about now. I want to talk about now what are called linear inequalities. So we were just talking about linear equations, right? Linear equations? I'll give you a second to write that down because I'm going to jump back here. Jump back. Remember this page? I said, let's talk about linear equations. I said, here's a linear equation in 1 variable. Here's a linear equation in 2 variables. Here's a linear equation in 3. Linear equation in 1, the answer was a point, right? Linear equation in 2, the answer was a line. Then we started talking about this is some sort of plane in 3-dimensional space. I'm changing now the equation. Instead of saying linear equation, I'm changing that to linear inequality. Totally different word, right? So let's see what the difference is between linear equations and linear inequalities. So here's an example. X plus 4 less than 10. So that's just like the one I had before, but I had the equal instead of this. What symbol is that? Less than. Has everyone seen these symbols before? That, and that. Those are our 4 inequality symbols that we use. This one would mean, the top right would mean that the left side is less than the right side. The second one says that the left side is greater than the right side. The third one says left side is less than or equal to the right side. The fourth one says that the left side is greater than or equal to the right side. Has everyone seen those before? Okay. So if I write x plus 4 is equal to 10, less than 10, sorry, then that's an inequality. It's linear because you have x to the first power. So this is a linear inequality, 1 variable. Let's talk about what the answer looks like. So what is the answer to this? X is less than 6, right? Subtract 4 on both sides. What does that look like, x less than 6? If you're on a number line, and this is 0, and this is 6, I'm saying everything to the left of 6. So we would kind of shade this entire side of the line. And since we don't want 6, you put like an open circle there. Some instructors use a parenthesis like that. But the whole idea is that 6 is not included, right? 6 is not an answer. Y'all agree? Okay, how would this problem change if I did x plus 4 is greater than or equal to 10? Greater than or equal to. Yeah, so I still subtract 4 on both sides, right? To get x is greater than or equal to 6. So now my answer looks like this. Here's 0, here's 6. I want everything bigger than 6, and I want to include 6. So instead of putting an open circle there, I put a solid dot, and then everything out to the right of it. These are linear inequalities of 1 variable, things that you've seen hopefully in the past. Now I'm going to I have to give you one more example because I want to make sure everyone remembers this one particular property of linear inequalities. All right. So how would we solve this linear inequality? Subtract 4 first, right? So I subtract 4. If I subtract 4, I get this. Does everyone agree with that? Yes. Now I have to divide both sides by what? -2. If you ever divide an inequality by a negative number, which we're about to do, right? I'm about to divide by negative. If you divide inequality, only an inequality, this of course doesn't work for equations because you don't have the symbol. If you divide inequality by negative number, what do you have to do? You must flip the inequality. Now, the reason why you do this has to do with the fact that when you multiply or divide two negatives, it becomes a positive. You know how that works with multiplication? Multiply two negatives, you get a positive, right? Or a negative and a positive, you get negative. It has to do with that. So it changes the sign of one side of the inequality, so we have to flip the inequality over, and then the other side is what? -3. So this would look like, on a number line, if this is 0, here's -3, it would be everything where? Which side? Right side. To the right. And do we include -3? Yes, so solid dot, everything out here. Y'all okay with this? These are linear inequalities in one variable. We're not interested in linear inequalities with one variable. This is just to motivate the idea and to make sure we understand how this worked. What we're interested in is linear inequalities in two variables. So that most of you have not seen. So that's where we go now. What does a linear inequality in two variables look like? So here's what we're going to have. Let's take that one we had earlier, x plus y. It was equal 10, right? Wasn't that the first one I gave us? Linear equation, two variables. Let's make it x plus y is less than or equal to 10. Well, this is kind of weird, all right, the way this works. We can't solve for x. I mean, well, we could solve for x, couldn't we? We could solve for y. I mean, we could do that. But that still doesn't tell us anything, because if you solve for x, you need to know what y is. If you solve for y, you need to know what x is. But we do know that this is a line, don't we? If I were to take this and convert this into x plus y equals 10, then that's a line, right? I'm converting it, all right? Convert to an equation, right? If it was an equation, which it's not, if it was an equation, I would have a line. And I could graph that line using what I know about y equals mx plus b, couldn't I? All right, so let me go ahead and do that. I'm going to draw this line quickly. It has a y-intercept of 10. And a slope of what? -1, which means down 1 to the right one, down 1 to the right one, down 1 to the right one. So it would basically look like this. Oh, whoa, what happened? It was funny. Come on, piece of junk. There we go. The line's in red. Oh, well. That all right? That's our line, right? But we want to know what x's and y's I would plug in to make it less than or equal to 10. So our answer, this line represents if that was equal, right? If that was an equal sign, it's this line. Does the inequality we have an equal sign in it? Yes, right? It has that equal sign, which means it's including that. It can be equal to it, which means the line is part of our answer. What do you think the rest of the answer is? Anyone have an idea? Okay, everything to the left, you mean like everything over here? That's correct. It's either going to be everything, we're not going to say left or right, we're going to say above or below. It's going to be everything below this line or everything above the line. So the entire sheet of paper, but like from a certain point down or a certain point up. The question is, which side of the piece of paper is it? Well, it can get a little tricky. So there's a very easy way to determine it. All you have to do is pick a test point. Just pick a point, any point you want. Plug it into the problem and see if it works. So first, does everyone understand that our answer is going to be a shaded part of the entire plane? All right, and that it's top or bottom, one or the other, but not both. Okay? To get the answer, pick any point that does not live on that line. So the easiest point to pick is the origin, 0, 0. So what I'm going to do now is I'm going to test the point 0, 0. Let's plug it into the original problem. X plus y less than or equal to 10. Is x plus y, is 0 plus 0 less than or equal to 10? Yes. That means that point 0, 0, which I'm putting here, that point is part of our solution, which means everything down there is a solution. We don't have to check every one, thank goodness. So my answer is everything here. And that's all I would want. But keep in mind, I mean, everything. That means everything. It would keep going down wherever this line is, below it forever. So there's this like infinite number of points. Yep. Well, yay. Okay, good. Let's try this. How about solving, did I go too fast or we good? How about solving this? X plus y greater than 10. Now that's almost the same problem, isn't it? Well, the first thing you'll always do, once you first determine this is a what? What is this right here? What do we call this? A linear inequality, two variables, right? As soon as you know it's linear inequality, two variables, you say, I'm going to first make it an equation. The equation will give you the line, okay? Now, we've already graphed this line, haven't we? So when I go to draw my graph and I draw this line, there's something very special we have to do here. So pay attention. We know that this line goes through, has an y-intercept up here at 10, right? Slope of -1. But do we want that line to be part of our answer? No, because our original inequality does not have the equal bar underneath, right? And this is what happens when we have equality. So the line is part of our answer if that equal sign is up here. But it's not, right? So this is kind of like the same thing when we had the number line and we had 6. We were saying, do you include 6 or not, right? If we included it, it was a solid dot. If it was not included, we left an open circle. So how am I going to put a solid dot open circle? Here's how we do it. I'm going to draw a dotted line. That's what I'll do, a dotted line instead of a solid line. So my line's going to go like this. It's not an asymptote, okay? It's saying, look, we have some barrier, but I'm not including anything on that barrier. So if you try and pick a point that lives on this line, it's not going to work. So I'm telling you, don't include it, dotted. See the difference between the two? Okay, now I need to figure out if I'm going to shade above it or below it. So I test a point, right? Now I'm going to test a point. Let me test 0, 0. Okay, if I plug it in, I get 0 plus 0 greater than 10. That's not true, right? That's false. That tells me that this point, 0, 0, that I tested does not work, which means everything down here does not work, which means everything on the other side does. You don't have to check it. Well, unless your line passes through 0, 0. Then you can't. So your test point can be any point that doesn't live on the line. I'm glad you asked that question. But 0, 0 is the most common one because a lot of times your lines don't pass. Man, we're doing good. It's actually fun, isn't it? Okay. So I've given you 2 examples, right? Let me remind you now. What we did a second ago is we said, hey, we're more interested in lines, right? And we said, okay, here's a line. And then we said, all right, after that, let's talk about systems of linear equations. And then we actually have 2 lines, and we try and figure out where they hit each other, right? And then I said, all right, here's a couple of examples, and here's an application. And then I started talking about inequalities, then linear inequalities. And now what do you think I'm going to say? System of linear inequalities. So now instead of having 2 equations and trying to find where they hit, what we're going to look at is something like this. Solve, let's say that x plus y less than 10. And then let's say 2x plus, or I'll say minus y is greater than or equal to -2. Let's see if you can squeeze out of your brain what the hell this is. What is the first one? When we look at the answer to that first one up there, what was it? When we drew the answer, what was it? It was a line and then everything above or below. And in this one, it'll be everything, it'll be below. We'll have to look at it, but that'll be a certain part of the plane, right? Shaded from the line down or line up, right? There's going to be an intersection where they overlap. And that's our answer. Does that make sense or not? So let me try and do these separately, all right? Meaning, let's talk about this first. Now, we've done that problem several times now, right? The first thing I would do is I would take it, I would make it into an equation. I would solve for y, and then I would draw a line. Uh-oh, the audio? Shit. Mother. What happened to it? Why didn't y'all tell me? Oh, no, it's there. It got frozen up. Woo! Woo, 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 woo. Hello? I think I'm here. Were you happy that the audio was lost? You were happy? That's kind of sick. It would what? Oh, stall time. Oh, it's not that bad, is it? Really? Is it really that bad? I'm sorry. Okay. So look, I'm going to draw this. All right, it's the same line we did before, right? Is it dotted or is it solid? It's dotted. So it's going to be up here at 10. It's going to come through, it's dotted. And tell me something else. Above or below for the shading? Below. So I would test what number? 0, 0, test 0, 0 into the original problem, it would work. Now I'm going to shade it a little different than before. Just real lightly, I'm coming in here with some red and I'm just shading below. Is that all right? That represents the first inequality, x plus y less than 10. The other one now I have to look at, right here. I'm going to have to come over here first and make it into an equation and solve for y. Is that okay? Can you draw that line? What's the y-intercept? 2. I heard someone say it. That's good enough for me. 2, and then what's the slope? Up 2 over 1, right? Up 2 over 1. So I'm going to draw it. Am I going to draw it solid or dotted? Solid, because it was the equal sign there, right? Now, I'm not going to be real good on my slope here. I'm going to try my best, but it's going to look something like this. Solid line. Now, is it everything above that black line or below that black line? Well, 0, 0 does not live on that line, right? So let me test it. Plug 0, 0 into this and tell me if it's true or false. I'm going to test 0, 0. I get 2 times 0 minus 0 is bigger than or equal to negative 2. That 0 is bigger than or equal to negative 2. Is that true? Is 0 bigger than or equal to negative 2? Yes. So that means I'm going to shade which side of the line? Above or below that black line? This point right here, 0, 0, worked. It is below that black line. So everything below. Well, no, just right now I'm looking at the black line separately. The black line separately is everything below, right? Everything like that? Well, I can on the black line, but not on the red. Now my final answer is where they overlap. So my final answer is everything in here like this. Right? Now, could you pick a point on the black line as part of your answer? Yes. Could you pick a point on the red? No, because that's still dotted. So it's this shaded region, and you include that line, but you do not include the red one. Our answers are going to be pictures, all right? They're not going to be like X is 2. We're going to have pictures as answers. Sure, graph paper, whatever you want, crayons. All right, so what I'll do is in the last 2 minutes, I'm just going to give you a couple of problems to do at home, all right? I know that's fun stuff. Okay, solve. Oh, not equal on that. Hmm. Now, I'll just give you some instructions on these. On numbers 1 and 2, you should have graphs. Okay, look, on 1 and 2, these are lines, right? Because look at their equals, equals. Those are systems of linear equations. So what we're trying to do is find where those two lines, wait, hold on. No graphs. No graphs. This is substitution. Okay, you're using substitution, and what you're doing on number 1 and 2 is you're finding the point that they intersect each other, right? On numbers 3 and 4, these are graphs, but these are not systems of inequalities. So for number 3, you're going to have a line, and it's going to be shaded above or below. On number 4, it's a line shaded above or below. And then next class, we'll do more of the systems where we have shading above, below, and 2 of them, then we find that where they overlap. We'll do more of that, but nothing like that for homework. Okay? See how you do on those 4. Have a good day. Sorry to have to end class. Apologize.